How Kawneer's Solector sun shading estimator tool evaluates thermal performance and energy savings. Welcome to Building Knowledge 101. In this video, we share examples of how our Solector sun shading estimator tool can help assess energy savings of sunshades on architectural aluminum framing systems. In order to effectively evaluate the daylighting and energy savings potential of sunshades, some manufacturers offer online tools that provide project-specific estimates of performance of the variety of configurations they're looking at. So let's look at a couple of examples here. Let's assume we're in Denver, Colorado. So here's a south-facing curtain wall project in Denver with a room height of 15 feet. The room is 30 feet deep and runs 50 feet along the face of the building. So we're going to put on it an outrigger that's both 30 inches and an outrigger that's 36 inches. So scenario number one is going to have an outrigger that projects out 30 inches. Scenario number two is going to project 36 inches, which is going to provide an additional 6 inches of shading. Also, I've put in the glass performance that's going to be required. So when we evaluate these, this is going to give us a comparison of these two scenarios and show the impact that each one is going to have versus a room without shades. So the design of scenario two is better than the design of scenario one. In terms of annual cooling energy saving, the extra 6 inches of projection provide greater amounts of shading, which reduce the energy costs that we have by blocking direct sunlight and solar heat gain. So from this report, we see annual cooling energy savings due to reduction in solar gains compared to no shading for the selected area. So scenario one with a 30-inch projection gave you 42% performance or better performance over the same elevation without a sunshade. Scenario two gave us 46.93% improvement. In this scenario, we're taking a south-facing curtain wall project in Key West, Florida, with a room that's 15 feet high, 30 inches deep, and 50 feet long. The fenestration is outfitted with either a 30-inch projecting outrigger or 36. It's located 12 inches below the head of the glass. And then we've given our information on the glass. Solar heat gain is 0.26, U factor 0.28, and visible light transmission of 0.60. So now we'll do an evaluation. Design of scenario two is better than design of scenario one in terms of annual cooling and energy savings. Annual cooling energy savings due to reduction of solar heat gain compared to the same room with no shading for both elevations. Scenario one was a 33.41% improvement. Scenario two was 37.04% improvement. So you can see the projection going out 36 inches does give you better performance over the 30-inch projection. You know, in this elevation, it's not as dramatic an improvement as we saw in Denver, because in Florida, Key West, the sun is higher in the sky, so it's shining down, so it's not shining directly into as much of the sun, the glass elevation, as it would have been in Denver. All right, so we're going to change the scenario a little bit. In this scenario, we're back in Denver, the same south-facing elevation. The room is 15-foot height, 30 feet deep, and 50 feet long. The fenestration is outrigged with either a 30-inch projecting sunshade or a 42-inch shade with integrated photovoltaic panels located 12 inches below the top of the curtain wall. We've got our glass performance information inputted. So now when we do an evaluation, the design of scenario two is better than the design of scenario one in terms of annual cooling energy savings. Compared to the same room without sunshades, scenario two gave us 52.69% improvement. Scenario one gave us 42% improvement. And then on top of that, with the photovoltaic panels on the sunshades, our annual power production is rated at 39.79 kWh. So we're also generating on-site renewable energy at the same time as we're shading the elevation. That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.